This timeline of evolution of life represents the current scientific theory outlining the major events during the development of life on planet Earth. In biology, evolution is any change across successive generations in the heritable characteristics of biological populations. Evolutionary processes give rise to diversity at every level of biological organization, from kingdoms to species, and individual organisms and molecules, such as DNA and proteins. The similarities between all present-day organisms indicate the presence of a common ancestor from which all known species, living and extinct, have diverged through the process of evolution. More than 99% of all species, amounting to over 5 billion species, that ever lived on Earth are estimated to be extinct. Estimates on the number of Earth's current species range from 10 million to 14 million, of which about 1.2 million have been documented and over 86% have not yet been described. While the dates given in this article are estimates based on scientific evidence, there has been controversy between more traditional views of increased biodiversity through a cone of diversity with the passing of time and the view that the basic pattern on Earth has been one of annihilation and diversification, and that in certain past times, such as the Cambrian explosion, there was great diversity. Extinction. Species go extinct constantly as environments change, organisms compete for environmental niches, and genetic mutation leads to the rise of new species from older ones. Occasionally biodiversity on the planet takes a hit in the form of a mass extinction in which the extinction rate is much higher than usual. A large extinction event often represents an accumulation of smaller extinction events that take place in a relatively brief period of time. The first known mass extinction in Earth's history was the Great Oxygenation Event 2.4 billion years ago. The event led to the loss of most of the planet's obligate anaerobes. The 5 largest extinction events in Earth's history since are these: end of the Ordovician, 440 million years ago, 86% of all species lost, including graptolites. Late Devonian, 375 million years ago, 75% of species lost, including trilobites. End of the Permian, the Great Dying, 251 million years ago, 96% of species lost, including tabulate corals, and most extant trees and synapsids. End of the Triassic, 200 million years ago, 80% of species lost, including all of the conodonts. End of the Cretaceous, 66 million years ago, 76% of species lost, including all of the ammonites, mosasaurs, ichthyosaurs, plesiosaurs, pterosaurs, and non-avian dinosaurs. Smaller extinction events have occurred in the periods between these larger catastrophes, with some standing at the delineation points of the periods and epochs recognized by scientists in geologic time. The Holocene extinction event is currently underway. Factors in mass extinctions include continental drift, changes in atmospheric and marine chemistry, volcanism and other aspects of mountain formation, changes in glaciation, changes in sea level, and impact events. Detailed timeline. In this timeline, Ma means million years ago, Ka means 1,000 years ago, and Ya means years ago. Hadean Eon 4000 Ma and earlier. Archean Eon 4000 Ma 2500 Ma. Proterozoic Eon 2500 Ma 542 Ma. Contains the Paleoproterozoic, Mesoproterozoic and Neoproterozoic eras. Phanerozoic Eon 542 Ma. Present. The Phanerozoic Eon, literally the period of well-displayed life, marks the appearance in the fossil record of abundant, shell-forming and/or trace-making organisms. It is subdivided into three eras: the Paleozoic, Mesozoic and Cenozoic, which are divided by major mass extinctions. Paleozoic era 542 Ma 251.0 Ma and contains the Cambrian, Ordovician, Silurian, Devonian, Carboniferous and Permian periods. Mesozoic era from 251.4 Ma to 66 Ma and containing the Triassic, Jurassic and Cretaceous periods. Cenozoic era 66 Ma. Present historical extinctions. Bibliography.